Bohr's atomic model, the formula. First, let's learn about the constant value. The first one is Rydberg constant. The symbol is RH. We have two values of Rydberg constant. The first one is 1.097 times 10 power of 7 per meter, and the second one is 2.18 times 10 power of negative 18 joule. The first value, the unit is per meter, and the second value, the unit is joule. The second one is Planck's constant. The symbol is H. The value is 6.6256 times 10 power of negative 34 joule second. The last one is speed of light. The symbol is C, and the value is 3.0 times 10 power of 8 meter per second. You don't have to memorize all the constant values sebab dalam exam ianya dah diberi dalam list of selected constant values. Yang ni dia ada bersama-sama dengan table of relative atomic masses. Next, let's learn the symbol in the calculation. The first one is wavelength. The symbol is lambda. The second one is frequency. The symbol is nu. Now we have come to the important parts of this video, which is the formula. The first one is wavelength. The unit of wavelength is meter or nanometer. The formula is 1 over lambda equal to RH 1 over n1 squared minus 1 over n2 squared. Lambda here must be in unit meter. Kalau soalan bagi lambda dalam unit nanometer, kena convert dulu ke unit meter. There are few remarks. The first one is about RH, Rydberg constant. As we know, Rydberg constant has two values. So Rydberg constant yang kita akan guna dekat sini is Rydberg constant in unit per meter. The second one is about N1 and N2. The value of N1 must be smaller than value of N2. And the last one is lambda yang kita calculate menggunakan formula ni, dia sentiasa positif. So if you all dapat negatif, that means ada kesilapan. Next is energy emitted or energy difference or energy of photon. Kalau jumpa tiga keyword ni dalam soalan, that means dia nak kita calculate delta E. The unit for delta E is joule. We have three formula for delta E. The first one is delta E equal to RH 1 over n initial squared minus 1 over n final squared. RH yang kita akan guna dalam formula ni adalah RH in unit joule. Using this formula, delta E can be positive or negative. That means delta E yang kita calculate menggunakan formula ni, dia boleh jadi value-nya positif, boleh juga jadi value-nya negatif. Delta E will be positive when electron excited from lower energy level to higher energy level. The positive value shows that energy is absorbed. Delta E will be negative when electron fall down from higher energy level to lower energy level. The negative value shows that energy is released. The second one is delta E is equal to h nu. H is the Planck constant, nu is the frequency. Delta E is always positive. That means, kalau kita kira delta E menggunakan formula ni, kita akan dapat delta E yang bernilai positif. Ataupun kalau kita nak masukkan nilai delta E dalam formula ni, pastikan delta E yang kita masukkan tu bernilai positif. I skip the third formula. We go straight away to the frequency. The unit for frequency is per second or hertz. The formula is nu equal to c over lambda. Nu is the frequency, c is speed of light, lambda is wavelength. Lambda in this formula must be in unit meter. So kalau soalan bagi lambda dalam unit nanometer, convert dulu ke unit meter. The third formula for delta E is the combination of delta E is equal to h nu and nu is equal to c over lambda. Kita akan substitute c over lambda ni ke dalam nu di sini. So kita akan dapat the third formula, delta E is equal to hc over lambda. H is Planck constant, C is speed of light, lambda is wavelength. Lambda in this formula pastikan dalam unit meter. So kalau dia bagi dalam nanometer, convert dulu kepada unit meter. Delta E always positive. That means delta E yang kita calculate menggunakan formula ni, dia sentiasa positif. Atau kalau kita nak masukkan delta E ke dalam formula ni, pastikan value delta E tu bernilai positif. The last formula is energy of electron in its level. The symbol is En. The unit is joule. The formula is En equal to negative RH 1 over N squared. Rydberg constant in this formula, we will use the Rydberg constant in joule. N is the energy level atau kita boleh tulis sebagai principal quantum number. I want to emphasize about Rydberg constant. We have two Rydberg constant. The first one is in unit per meter. The second one is in unit joule. Kita akan guna Rydberg constant dalam unit per meter bila kita nak calculate wavelength sahaja. Sebab wavelength dalam unit meter atau nanometer. Kita akan guna Rydberg constant dalam unit joule bila kita nak kira energi, delta E dan juga En. Sebab energi adalah dalam unit joule. 6 formula ni tak diberi dalam exam. So you all kena memorize all these 6 formula. Thank you for watching.